Welcome to this presentation about Apache Kafka Exposed. 5 revelations every API developer must know. Based on my previous experience, Apache Kafka looks for different people, depends on where they're coming from and depends on their experience, as some sort of very interesting and mythical creature. Everyone seems to know what Kafka is and how they can use it. But every time when I'm talking about this, it reminds me this old tale where the 4 old men first time met an elephant. They were old and their vision was not that sharp as it used to be. So they tried to approach this creature and they touched the different parts of this creature. Someone touched the nose, someone touched the tusks, someone touched the tail. And depends on this part of this body where the people touching this, they try to figure out what kind of creatures it was. The snake, was it as a python, or maybe, I don't know, like something else. So similar situation I've experienced when the people first time talking about Apache Kafka. What is Apache Kafka? And the answer is always depends who are you asking about this. If you're talking to messaging people who spend their life building message-oriented middleware and infrastructure for data processing or infrastructure for some data-intensive applications, they might have a different answer. And today I'm going to try to, as an API developer, what API developer needs to know about Apache Kafka and how they can use it. Hi, my name is Viktor Gamov, and I work as a principal developer advocate here with Kong. And I'm also happen to be one of the co-authors of widely successful, worldwide bestseller from the Manic publisher called Apache Kafka in Action. In the bottom of this slide, you can find my Twitter if you have any questions, or just if you're interested in the world of API, big data, and all things open source, you can follow me there. So there's a quick agenda about the things that we're going to cover today. I will introduce you to this concept of event-driven architecture and how it's different from the traditional REST-based web services and things like that. I will talk about Kafka basics, what kind of elements of Apache Kafka you have to know as a developer, and how it is relevant for you if you came from the traditional background and you know the REST endpoints, the REST stuff, and you may be user of some of the tools that allow you to share and publish open API specs and things like that. So in this presentation, it is quite inclusive in terms of who can listen to this. It's basically one type of talk where if you have no prior knowledge about Kafka and you want to learn some of the basics, that's the right place to be. There will be any product announcements or some of the things that I will be talking. It's just solely my experience and my thoughts being in the front lines, talking with developers and talking with the open source contributors and all this kind of thing. So there would be nothing in terms of what the Kong will be supporting or supported today or will support in future. Okay, that's the thing. So let's gonna start with the introduction to event-driven system. So I could use this just to talk to you about event-driven systems, talk about the different parts of it. But what I decide to do, actually, let me show you. And let me show example of this event-driven system based on the ride-sharing application. So I do have a ride-sharing application that consists of 2 parts. I have a driver screen that we can see the drivers over here, and I have a rider screen. And if the rider wants to hire the car to go and pick up it from, let's go to New York. I live close to New York, so travel to New York is a thing. On the driver side of thing, when I click this, I see my rider appear here. And as a driver, I will be able to go and pick them up. So when I click to the rider icon, so what's going to happen here? 2 applications now communicating to each other, sharing information about each other locations. And my driver will arrive for my writer, so my writer would know, when it will come for them. This is a real-time application, so the time in order to get to the point where our driver, from place where I am to the place where the writer is, will be roughly 20 minutes. At the end of the talk, we will see if the car arrived this. But what you see here is what your users see, but what they don't see is actually there is a whole infrastructure that sits behind this, and this infrastructure driven by Apache Kafka. So let me quickly show you my Apache Kafka console powered by Red Panda. And with the Red Panda, I will be able to see two components, so two topics, what we called. We're going to be talking about those things in a second. Two topics. One, we use the information about location of the driver. And if we go and see different messages, we can see there's the identifier. This is information about latitude and longitude and the status. And right now, we know that our driver from this going to pick up our writer. And we can see there's multiple things going on here. Immediately, we're going to be talking all things later in this presentation. But one of the things that you can see here is that let's now see the writer topic. For the writer, we have an idea of writer. It sends coordinates of this writer to driver. So driver will be known if our writer will be walking around. So driver will be able to pick up this. So, like I said, a lot of things going on, but one of the common things that you need to understand from perspective of event-driven systems is that different things will happen in your application. Your application will react on the different events that happen in real life. What's the event? Event is occurrence. Something has happened. Event, like it's happened in the real life, something that happened and it's immutable. You cannot change it. So think about this like something that you have a conversation with your significant other and you said something that you were not supposed to be saying. So in order to change that, you don't have a time machine to go back and change it. So you need to send another event, another message. So your incoming component of the system, the component that will be listening for those events, needs to react based on the next event. So that's an important thing to understand. Conversation or interaction between the system happens in events, and only receiver or consumer, how we call this in the Kafka world, would be able to make sense out of it based on the message content. The good thing is that Kafka really doesn't care. So we're using Kafka here as an example about what type of payload here. So in this particular case, it is a JSON. So we will be able to introspect this, but it also can be a binary information and so far and so on. So let's quickly observe our application if the cars are still moving. Car is still moving. It's going slowly but steady. And those two screens are synchronized. So those cars are moving with the regular speed, even though the scale of the map might be different. But trust me, they're moving with the same speed because the driver sends a location of itself through the Kafka topic, and the writer reads this information from the Kafka topic and puts this on the screen. So that's the example of event-driven system. And whenever I will be talking about the next steps in our architecture, specifically about the basics of Apache Kafka, keep in mind this picture, how the systems will interact. Someone is sending messages, and someone will be receiving or consuming those messages. This is the picture from the developer.confluent.io website, where you can find a bunch of different educational resources. But this gives you like a big picture how Kafka can be used. So the simple possible way how it can be used to write events into Kafka topics, and someone else will be consuming those. One of the examples of this, you have a system that will be collecting clicks on the website, how the user interact, and all this data will go inside the Kafka. Next thing is that you need to process this data somehow. You can write your apps using Kafka APIs on your particular language, or you can use more or less standard SQL, streaming SQL, using KSQLDB or Apache Flink or something like that. Also, there is a variety, just like myriad of different connectors that allow you to connect virtually any data source that's available out there for Kafka consumption. So that's the big picture. Go to developer.confluent.io and you can find more of this. Now, so let's talk about Kafka internals and how the things happen inside the Kafka. I already mentioned this concept called topic, and if you came a little bit of or familiar with the message-oriented middleware world, you know that the topic is something that you can subscribe and receive the messages. But not many of you know that the topic is basically virtual concept. More important concept inside the Kafka. It's called Kafka partitions. So we're gonna see how those the lines, as you can see, this dotted lines of these interstate or highway will be represented the Kafka partitions also very well. So Kafka itself, it's a append-only log file. So meaning that every time when you need to write new message, this message will be placed at the end of the file. This operation generally lightweight, so you're not wasting a lot of time trying to insert a large variety of information. Writing at the end of the file is relatively cheap operation on operating system, so that's why Kafka leverages this, and writes to Kafka is usually very fast. One of the messages or events that we're writing inside the Kafka will include some payload that you need to use and some of the additional metadata. So let me quickly show you in this the Kafka console how those things are looking in our particular case. So we have a key that will represent ID of our driver. It has a value that will represent the actual coordinates of our rider or driver. Some of the things that it can include some additional metadata. In this particular case, it can include header. It can include information about offset. We're going to talk about offsets in a second. Timestamp and other things. So let me quickly, if I click refresh. So my offset changed, meaning that there would be more messages now available inside this Kafka topic. So let's talk about the way how the messages are placed inside the Kafka topic. So each individual topic is a collection of the partitions. And the topic is, like I said, it's a virtual concept that creates a collection of partitions. Partitions, it's a unit of storage inside the Kafka, and it can be spread across multiple different Kafka broker nodes. Kafka is a distributed system. The partitions spread across multiple different physical nodes. Topics, very similar. You can conceptually or semantically, you can think about this as a tables in your database if you're familiar with this concept. So it might have a transactions. In this particular case, it will include all the list of transactions that happen, orders, users, and user interactions, and all these kind of things. Different partition will have each topic will have a different partitions. And those partitions might not necessarily be on the same machine. Even though when you're writing some messages into Kafka topic, you think that you're writing to one particular place, but in reality, you're actually writing data into partitions. And the messages are guaranteed to be strictly ordered within one particular partition. So let's talk about the clients who write and read data from Kafka topic. We're going to start with producers. And you might notice this, some of the images here look like they were either stock images or AI generated. Since it's a 2023, yes, those are AI generated, and I ask AI how this queue of producers would look like. So we do have a producers that's standing here. So producer is a type of Kafka client that is responsible for sending messages to Kafka topic. There is certain rules about how those messages are end up into Kafka topic. Specifically, based on the message key, we will be able to define rules of routing of these messages. There is also very important quality of the producer called idempotent producer that allows you to eliminate risks of duplicates. There's some very interesting mechanics and as built inside this client that prevents from the producer sending same message twice. When you're sending the same message twice with your application code, it's totally normal. Idempotent producer only prevents you for accidentally send duplicates in case of there would be network retries or there would be no acknowledgement received from the Kafka broker and so far and so on. So idempotent producer, it's a very low level concept, but it is very important concept in distributed systems. You don't want to have some transactions that happen twice and recorded into your account, twice withdraw from your account just because there was some network blip and the server didn't send the response. So producer thought, oh, okay, so I probably need to resend this. Idempotent producer prevents from this. Also, producer, it is very also optimized to do very large number of writes through batching. Also, if you have a large amount of data that you need to transfer, compression is also available on the producer side of things. As I mentioned earlier, messages are added to the end of the log. And if we don't provide any keys for this message, as you saw in my example, I use a key as the ID of my driver. But there are some situations where you don't know key or you don't have key or whatever. And based on this absence of the key, partition where this data will be stored inside Kafka topic will be chosen automatically based on the round-robin fashion. There is some other policies available. I'm not going to go deeper inside on those, but like think about this if you're not providing key, producer will take care of the placing this in the right place. If you're providing the key, your messages with the same key always end up in the same partition. If you want to collect the transaction that happened for the same credit card with the same card number, you will know that in the partition 1, there only would be credit card transaction from my credit card with my unique number if I would choose to take the key for my partition. Now let's talk about consumer. How are we gonna reading this data? And that's why I brought this like very nice picture when mommy bird will bring some of the worms to baby birds and start feeding those. In the Kafka, consumption happens based on the consumer, and the consumer organized in the consumer group. So the consumer group coordinator will be responsible for assigning those different partitions for particular consumers in order to consume those. So in this case, consumer group coordinator is a mommy bird. It will be responsible. It's a component sits inside the broker that will be responsible for assigning those partitions, those tasty worms to the baby birds. Baby birds are consumers, and this nest is a consumer group. If someone will fall out of the consumer group, mommy bird or consumer group will be responsible for rebalancing these consumers or redistribute the load of these applications. Consuming data also happens sequential. We cannot have a random access of the data. Based on the offset, we read the data sequentially. Think about this as you have a book. Kafka is a book, it's one immutable place, and in order to multiple different consumer reading the same data, they actually need to store information where they stop. Think about as a kind of different people have a different colored bookmarks in order to remember where they stop. We have say Robin fella here, Vic here, and Ricardo here, and they have a different way of reading things, different speed of reading things. But they always, if something will happen, some of the disconnection or network break or whatever, their position will be stored inside the Kafka, inside offsets topic. So one consumer can consume from the all partitions, but if you want to scale reads, you can introduce different consumers. And like I said, consumers are not in the same consumer group will be reading this data from different places, same way as different people reading same book, but from the different place using different bookmarks. You can scale these reads, introduce more consumers inside the consumer group, so you can scale and make this read in parallel. So you cannot have more consumers in the consumer group more than the number of partitions inside the Kafka topic. But if one of the consumers will fall out of the nest or fall out of the consumer group, it will be replaced and some of other consumer will pick up and will continue to work. In this particular case, C3 is picking up a load from partition 3 and partition 4. Kafka known to have this so-called exactly once semantic. And this semantic is not coming from producer, Kafka broker, consumer, how many people think, but from the point where we need to consume, do the process, and produce output to another topic. That's whole exactly once semantic how it works. So say we do have two Kafka topics. We need to read data from Kafka topic, do some processing, say calculate or filter or whatever, and write data to another topic. So the results would be filter topic. Or we need to do multi-stage thing. We need to do filter, and after that we need to do aggregation. So those things covered by Kafka exactly once semantic. Those operations can happen within one atomic operation. And if something will happen somewhere in the, say here, over here, something will break, we will be able to start over without introducing duplicates or creating some wrong data. And there is a built-in framework that supports this out of the box. Right now, there's a few other frameworks available who support this exactly once semantic, but Kafka Streams was one of the first because it's built-in inside the Kafka. There's also ability to coordinate with external resources, but it will require some external knowledge. For example, requires some external transaction coordinator. So that's why if you need to deal with the external databases and external systems, in order to have exactly one semantic end-to-end, you need to have external coordination here that understand also Kafka exactly one semantic. All right, and the last but not least, okay, so you understand all this. You have a producers, we have a consumers, we have all this, okay, whatever. So how are we gonna use this? There's a plenty of different Kafka clients, but the most important thing that you need to understand, Kafka works on the lower level protocol versus how your REST endpoint works. Kafka works on the TCP IP level and communication happens there. Your REST endpoints work on the the HTTP level. So it's not a good idea to expose Kafka to outside world. You need to have some sort of protection or proxy. Usually people putting something in front. But let's imagine you build an application that interacts with Kafka within your organization, and you need to provide the very similar way how to describe what kind of data you have there. For this, we basically meeting two technologies, streamings and API. As you can see, streams that's how the Midjourney sees the request about how the streams, data streams fit into API world. So there is a concept very similar for many very familiar developers for OpenAPI spec called AsyncAPI spec, and it is a blueprint to describe a event-driven system, describe what kind of system it is, abstract it from the transport, because event-driven system, it doesn't mean that you have to use Kafka. You can build event-driven system on top of other technologies like RabbitMQ, ZeroMQ, some other message-oriented middleware, as long as there's a support for these specifications. So AsyncAPI, it's the standardized way to describe your event-driven API. It is a way how you can provide documentation, same way as you provide documentation for in the form of OpenAPI spec to your consumers or to one who will be users of your API. Provides the improved developer experience, so you don't have to guess about the format of the data that you're putting there. And also simplifies integration by describing this and providing clear understanding which topic includes what. So here's the screenshot from the AsyncAPI website that you have a back-to-back comparison between OpenAPI spec and AsyncAPI spec, and you have a very similar info, servers, sets, but you can see there is a difference in your open API spec. You have a pass, and in AsyncAPI, I have a channel that will have where the data coming from. So you have a request response here, but here you're talking with messages, and message will include headers and will include payload that allows to do certain things with the system. And there's some other things that you can also do. There's a schema for the different components, and there's also schema available for AsyncAPI and for Kafka. There's a component called schema registry that stores data formatted in a special format. It can be a JSON schema, it can be Avro, it can be protobuf. So that's the similarity. But in this case, it will be up to generator that will be produce particular schema in a particular implementation. So it's more like implementation details. So there's a tool called AsyncAPI Studio that is available on the AsyncAPI website, and you can play around with this and you can navigate. There's a very similar to the servers how we have in our in our open API spec, and we can see what kind of security protocol here is used. So this can be used to connect directly to those. You can see what kind of operations available in this particular case. We can see format of the data, we can see the payload, and we can see the type count, timestamp, and things like that. And also there is a message. Basically, that's the schema of the message and things like that. So there's a generators that can take this open API, AsyncAPI spec, and after that spits out the results in the form of some of the code that you can use in your application. All right. So that is AsyncAPI. So, and before we part, I will just do a quick recap, and we can check if my application is still working, and my application in my driver arrived for my writer inside the in my application. So today, what I was telling you, and hopefully you learned something. Why of event-driven system? It's a different breed of architecture that will include communication through passing messages from one place to another. Messages are immutable. You cannot change those. You can replay those. We didn't talk much about this, but this is very important quality. So in case of you want to open up some of the new capabilities, you might replay some old events, and after that, do something with this data absolutely new that was not intended to do. You learn about basic Kafka concept. Kafka partitions is the way how the data is stored in, again, immutable fashion, a write-only, append-only log file. You learn about producers, that is the type of client that writes data inside the Kafka topic. Consumer and consumer groups, how you can read and parallelize reads using consumer and consumer groups. And a little bit touch of how exactly Once Semantic works from within the framework that sits inside the Kafka. Read data from Kafka topic, process data, and write back to the Kafka topic. And also, you learn about how AsyncAPI can be used to documenting Kafka and documenting the contents of this application, contents of the messages. Let's quickly take a look for the one last time to our application. As I told you, the system is more or less real time. So it takes roughly 25 minutes to get to Manhattan, and my car right now somewhere in Lincoln Tunnel, and it's coming to our driver. So, but we're not gonna wait until the end because that's all the time that I have for you today. I'm always open for conversations and open to answer any questions what you have. I hope you're enjoying this API Summit organized by Conk, and my name is Viktor Gamov, and as always, have a nice day.